Good day, college algebra class. Today we're going to be going over lesson 3, rational linear equations. This will be a first part as I'm going to be breaking this video up, as this is a 8-page handout, and if I do the whole thing at once, it's going to be kind of a long video. So I'm giving you guys a little mercy, both for you and for myself, and going to break this up just a little bit. So start off, a rational linear equation. It's just a linear equation that is a ratio of two linear equations. Now, if you think about the name, rational linear equation, it flows with the rational number that we've been exploring earlier, right? A rational number is just a ratio of two integers. A rational linear equation is just a ratio of two linear equations. So oftentimes the variable will be in the denominator. And as a reminder, the denominator is in the bottom of the fraction. And when this is the case, this will complicate our work. We do not want the variable in the denominator when we are trying to solve the rational linear equation. So what we're going to do is we're going to use the lowest common multiple to make the equation easier. And what is the lowest common multiple? The lowest common multiple of two or more numbers is the smallest positive number that is divisible by each number. Okay, so let's explore this idea before getting into our equations. So let's look at the lowest common multiple of 5, 10, and 15. So we've got 5 here, and we'll be factor treeing each of these. 5 is only divisible by 1 in itself, so we leave that alone. Now we look at 10. And 10 is divisible by both 5 and 2. And then we have 15, which is divisible by both 3 and 5 again. And we note that 5 is present in all three numbers. So our lowest common multiple will be 5 and times 2 times 3. So that's it. Multiply through, and we find the lowest common multiple is 30. So just look at the steps, right? Basically, you break each number down into its components. If you have a number that repeats for all the numbers in question, 5, 10, and 15, in this case we had 5, you only write that once. If you have a number that appears in one but does not appear in another, then you just put it down by itself, as you saw we did here and right here. Okay, so with that in mind, let's move to the next problem here, or next page, I should say. We now use the lowest common multiple, the LCM, to solve the following rational linear equations. And we've got an important note here that if the value of x causes us to divide by 0, right? If the value of x causes us to divide by 0 in the original equation, that is, the equation before we did any kind of manipulations to it, before we added, multiplied, or divided anything. If a value of x causes us to divide by 0 in that equation, then the answer is no solution or does not exist. Now, x can take on a value of 0 if it's in the denominator. That's okay. What cannot happen is whatever value of x you have cannot cause you to divide by 0. So for instance, if I had 1 divided by x plus 2 as part of the problem, then x could take on a value of 0, but it could not take on a value of 2, because 2 would cause us to divide by 0. So with that in mind, let's move forward. Note that if x equals 0 here and here, I will be dividing by 0. So we know right off the bat, x cannot equal 0. Okay. And let's look at our lowest common multiple. We've got 10 times x, we've got 5, and we've got 15x. And so, breaking these down, we've got, of course, 10 times x, and then this is 2 times 5. 5 is all by itself. And here we've got 15 times x, and we've got 3 times 5. And so we've got 5 present once again in all 3. And everything else is unique, right? We've got an x here and an x here, but we do not have an x and 5. So our lowest common multiple will be 5 times 2 times 3 times x. And note that this is simply 30 times x. All right, that's it. That's our lowest common multiple. So we're going to multiply our lowest common multiple by both sides of this equation, and that's going to clear out the fractions so we don't have to worry about them anymore. So we've got 30x times 1 divided by 10x minus 8/5 equals 30x times 2 divided by 15x. All right, so let's get to work here. Distributing this 30x to both terms, 30x divided by 10x, well, that is just 3. And then 30x divided by 5, well, that's going to be 6x. So we have 6x, and then don't forget that number up top, the 8. And then come on over here, 30x divided by 15x is 2. And don't forget, we've got that 2 hanging out right there. Okay, so now we have a much nicer problem statement to work with. And let's go ahead and start working it down. So 2 times 2 is 4. 6 times 8, that is 48. And then we've got our 3 hanging out there. And so we subtract 3 from both sides. And then divide by negative 48. And that would be our answer right there. Negative 1 over 48. Okay. And then we double check. X cannot be 0. Note that this is not 0. So this is a appropriate answer. Now, if we worked through all this and we found that x equals 0, and then we went and saw that we wrote x does not equal 0 here, well, that's when we would write does not exist, or D and E. But they don't match, so we're good. So let's move forward. Next one, first we notice that if x equals 2, that will cause me to divide by 0. And I don't want that to happen. So I'm going to simply state x cannot equal 2. All right? I'm going to just keep that in mind. The lowest common multiple is x minus 2. So I'm going to multiply that by both sides. And so I got x minus 2 times 2x plus 1 over x minus 2, right? Just both sides. Okay, and so we see the x minus 2 divides out in both cases, leaving us with 2x plus 1 equals x plus 3. And from here, we just work the problem, subtract x from both sides, and subtract 1 from both sides. And so we'll have an x equals 2. And so we find that x equals 2. But note that we already said x cannot equal 2. So therefore, we would say no solution, or simply x equals does not exist. And that's it. And note that if we worked through this and we found that x equals 0, that would have been perfectly fine, right? It's because 2 is what causes us to divide by 0.